Hey everyone, I'm DJ Schleen, and today I have Aaron Rinehart with me. Aaron, how are you doing, man?
I'm doing marvelous as always.
Excellent. I hear you got a new book coming out or out on the streets. Which is it?
It just released. It is coming. It was just released. It is out. It is the official animal book on chaos engineering. There are a couple other books from O'Reilly. The reports. They're like the O'Reilly reports, which are like 90 pages. Um, this is like the official book. The one on how to do chaos engineering. One on who's doing it. How to mature. What the maturity life cycle looks like. You want to learn about like this is the beyond Netflix story, right?
Oh,
Uh,
nice.
I wrote the chapter on security chaos engineering, and I'm currently actually writing the O'Reilly book on security chaos engineering, which comes out in June.
Oh, sweet, man.
Well,
So that's
so,
in June. Dang, so you got a
so
couple
this
books this
this
year.
this book, yeah, this book is already out. You can go to Amazon.com and like it's this one is System Resiliency and Practice, Chaos Engineering System Resiliency and Practice. It's written by two of the people from Netflix. There's the core authors, Casey Rosenthal and Nora Jones, were the core authors. And then there's a bunch of contributing authors. All the contributing authors and authors got their copies today.
Oh,
Uh,
wow.
so
Hot off the
it's
press.
hot off the press. It's all over Twitter. All the authors are getting it and posting it. But it's like one of the problems with chaos engineering is that there's no body of knowledge, right? Meaning that like there's blog articles from Netflix, stuff from me on the security chaos engineering on opensource.com. It's just like uh, blog articles and like open source projects, people trying to figure out how to do it. This book is people can pick it up, learn the techniques, learn how to do it right, how to make the breaks for it, how to do it with security, how to have a conversation with your management, and how to do it properly. It's not about breaking stuff in production.
So
It's
what
about
is chaos engineering? Like for those who are just watching and either new to the term or heard it before and wondering what it is, give us a 30,000 foot summary of what chaos engineering is and what it can do for us.
so I'll give you my definition of it. So everybody's got to kind of their own. Netflix has one on principlesofchaos.org, but my definition is it's the proactive. It's the idea of proactively introducing turbulent conditions into proactive, right? Proactively introducing turbulent conditions into a system or service. Try to determine the conditions by which it will fail before it actually fails. Like and so how we're currently learning about like unforeseen events is that they cause outages and incidents, and then we those aren't very good times to learn about the failures in our systems. What chaos engineering is the only proactive way to identify that residual failure before it causes customer pain.
So when you're talking about security chaos engineering, how does this chaos and how does chaos and security go hand in hand?
Well, so chaos for security, it's really the craft is not a whole lot different. It's just the value cases is a little different secure for security. I was an engineer for most of my career before I ever got into security. So I've never seen like the system and its security. I've seen either the system is being secure or not. Uh, and so the chaos engineering stuff made a lot of sense to me as like, as okay, well, you guys are just not including security in this conversation really. Because I mean, what I originally used chaos engineering for United Health Group was control validation. Was to prove whether or not when certain conditions arose, the controls we put in place actually fired. And what we found out is almost never is that the case. And it's an engineer's fault, a software engineer's fault, or security engineer's fault. It's just that the size, scale, and complexity of the systems we're dealing with now are very easy for people to make mistakes, right? You're making a change to an AMI. Oh yeah, I like saying the word AMI. Somebody instead of saying AMI, I'm saying AMIs for now on because it sounds cooler. Um, so if you're like somebody wanted to, they weren't sure what permissions they needed on the AMI or whatever, so they left a few things open, and they're gonna go back and fix it, but they had 10 other things. Like it's just what it is this like if you look at breaches that are happening, it's not like sophisticated stuff. It's like mistakes and accidents. And the majority of malware, if you go out there and look at it, it requires some kind of low-hanging fruit for it to be successful to begin with. Now there's a percentage of malware that's very sophisticated code, but the majority of it is crap software, right? It's trying
So
to figure.
yeah, so you're basically intentionally injecting failure into the code to create higher quality code into the system, right?
Yeah, and try to determine whether or not, like, so there is a difference between our mental model of how we believe the system works and how it works in reality. And it's because, like, John Allspaw, one of the creators of DevOps, right, likes to say that real work is messy, right? It is. Engineering work is messy as hell. I mean, like, how does a system become stable, right? If you work at a company and you're an engineer and you have a stable system at a company, that system at one point was not stable, right? How did it become stable, right? Like when you look at things like Kubernetes, like, oh, we're moving a legacy stable app to Kubernetes. It's like, worried about it being unstable. Well, how did this other app become stable? Like it was through a series of unforeseen events and outages. If you could have foreseen the events, right, like you would have fixed them, right? But like, but waiting for an outage to happen is you're encountering customer pain and business outcomes that are not ideal, but that also creates the opportunity. It's not a good opportunity to learn in. The blame, name, shame game starts to get introduced into things. People are worried about their jobs. Like, shit, I know I shouldn't have pushed that code, right? Like, and that's what we're able to do with the security chaos engineering in general is help ensure those kind of things, our assumptions about what we built. Because I think about it, we're changing. Once you get to continuous delivery and public cloud computing and microservices, I mean, things are just changing so fast. I mean, it's impossible for us as humans to ensure that that to keep track with the computer. That's why we have the computer, because it does things humans can't keep track of. You know what I mean? Anyway.
No, that's great, Aaron. I appreciate you sharing some of the knowledge on chaos engineering today. Where can we find out some more information about chaos engineering, since there are limited resources right now? Obviously, we have the book. We have your book coming up this summer. Where else can we go in the meantime to get some more information?
Well, folks can reach out to me on Twitter if they want to. It's at Aaron Rinehart, AARONRINEHART. There's also the Verica.io website. So I co-founded Verica after I left United Health Group. I co-founded Verica with the creator of Chaos Engineering, Casey Rosenthal. He's actually the core author of this book. And Verica.io, we actually have a sign up for a free mail copy of the book. So that's being released today. So if people want to go there, and they can just sign up on there, and yeah, we'll shoot people copies of the book.
Well, great, Aaron. Thanks for joining me today as we talked a bit about your book. I'm going to head right over to verica.io and pick up a copy of that right now.
Always a
Thanks
pleasure,
again.
DJ.
Take care.
Bye, brother.